Good morning, everyone. Welcome to Lesson 18, or good afternoon, depending on what class you're in. Okay, so let's get to this. So, Lesson 18, we are talking about finding surface area for three-dimensional figures. So, yesterday we were doing it with nets, and so we're kind of going to use nets today and three-dimensional figures without nets. So, this first question asks us, what three-dimensional figure will the net create? And you're like, where is the net? So you should have a second page with a net that you can use to answer all these questions. So I'm going to go to that page right now so you can see what page I'm talking about, and then we'll go back and answer all these questions. So the page that you should have looks like this, and it's just a net. So as you are looking at this net, you should be checking it out, and you're thinking, or you should be thinking, that there is, it looks like this shape right here, this rectangle, and this rectangle. If you folded it all up, those would be across from each other, and so this is going to be which is actually the first question. It's a rectangular prism. So on question A, when it says what three-dimensional figure will the net create, it's a rectangular prism because we have, this rectangle, and that would be across from this rectangle. This would kind of make a rectangular pizza box. Maybe one of those long rectangle pizzas for all the weirdos that don't like round pizzas. So the next thing it says B is it says measure in inches and label each side of the figure. So take a second and bust out a ruler and measure these actual things. Ready, go. Okay. You can pause it if you need to, but I'm going to move on. So you should have measured it, and so I'm not actually measuring this, so I don't know how exactly close it is because I don't have a paper copy. So if yours are a little bit off, then let's just say that we rounded. So you should have measured this across. Let's say we're measuring this top one across right here, and this should be like, this would be 4 inches, and which would make all these other lines 4 inches. So this is 4 inches, 4 inches. All these ones across are 4 inches. They're all the same width. So those are all 4 inches across. And then if you measured these guys right here, this would be 2 inches. So this is 2 inches. This one's also 2 inches. And then when you measured all these short little lengths right here, you find that they're all 1 inch. So these would be 1 inch, 1 inches, 1, 1, 1, 1, 1. They're all 1. Okay, so then it says move on to C, and it says calculate the area of each face and record this value inside the corresponding triangle. So I'm going to use, let's use a green for that. So the first rectangle I want to look at is this one right here. And when I'm looking at this red one, right, this is the base, I know that it's 4 across. And then I need to know how high is this red rectangle. Well, this line right here is going to be the same as this. So that's also 2. This is also 2 right here. So these rectangles are 4 by 2. So this would be 8 inches square. Now this is, down here, is also going to be 8 inches squared because they're both the base. Okay, and then using the same kind of methods, 1 times 2 is 2, 1 times 4 is 4, so looks like these are going to be, this is going to be 4 inches squared, so this one's 4 inches squared, 2 inches squared, 2 inches squared. So I've drawn a bunch of stuff on here, so just to recheck, or just to rephrase what I was coloring. The red stuff, that's just showing the bases. The blue colors are the edge lengths, so these are 1s, 2s, 1, 1, 4, 4. The green is the actual area. So D says, how did we compute the surface area of solid figures in previous lessons? So what we did is, we know that this makes a three-dimensional figure if we folded it all up, and so we're trying to solve for the surface area, and so we find the area of each face and then we add them all together. So if I want to do that, if I want to write an expression for that, I could say, I have 8, I'm going to write it down here, I would just have 8 plus 8 plus 4 plus 4 plus 2 plus 2, or, notice how there's 2 of each of these. I could use the distributive property and I could say I have 2 8s plus 2 4s plus 2 2s. This would be the same thing. Either way, just writing an expression to show everything. You could have also done an expression showing, you could also say, 2 times 1 plus 2 times 1 plus 4 times 1 plus 4 times 1 plus 4 times 2 plus 4 times 2. But that would be really long. And so moving on to F, I'm just going to stay here. So moving on to F, it says which does each part of the expression represent? And that would be each part of the expression represents one of the faces. So this is a part of the expression that represents this face. This represents this, this 4. Each one of these 4s represents one of these. Each one of the 2s represents one of these. So they each represent a face. And then finally G says, what is the surface area of the figure? So the surface area of the figure would be 16 plus 8 plus 4. So, or this would be 14 right here. 8 plus 4 would be 12 plus 2 is 14. 14 times 2 is 28. So I know that the surface area equals 28 units squared. And you might be thinking, whoa, why is it squared? I thought this was a three-dimensional shape. Well, right, but remember we're doing surface area, so we're still talking about flat surfaces that cover something, not actually fills anything. So those were all the answers for these guys, for the opening exercise. Now I'm going to move on to the first example, which I believe is on the next page. Yes. So example 1, I'll try to do these fairly quickly. And if you get the first one, you'll probably get the second one. So here we go. Example 1 says, fold the net using the opening exercise to make a rectangular prism. So you can actually or have the two faces with the largest area be the bases of the prism. I actually showed you what those were those were the red. And then fill in the second row of the table. So we have actually already found what all of these things are. So we would end up with a this is, the area of the top, right? Our bases in that last one were both 8. And, these are all inches squared, but I'm just going to write the number. So these were both 8, right? And then the front and the back, we'll say that's 4. We'll say those are 4. And the sides were 2. Okay, so these are all inches squared. I guess I'll just write it in. So then, that is that first one. So then moving along, it wants us to, what's it doing? Oh, so what this table wants us to also show is, this was the area, and I'm kind of skipping steps here, but it wants us to kind of also show that was, this was 2 times 4, which was the length times the width, but whatever, we already know what those things are. Anyway, moving on down here, we'll use the actual table for this shape. So this shape says examine the rectangular prism below and complete the table. So we've got a bunch of different shapes here, but this one's not in a net anymore, so we actually have to kind of visualize the different sides. So, you know, area of the top and area of the bottom. So when I'm looking at this shape, we can't actually see the bottom, but we can't see the top. So I'll actually, you know, scribble this in. This is blue, that's the top, and the bottom is down here, underneath. So the area of the top, well, I know that because if this is 15 right here, then this is also going to be 15, and if this is 6, then this is also going to be 6. Or I can say that, you know, this is showing that the bottom is 15 by 6. So I know that both the top and the bottom, since they're opposite one another, they're both going to be 15 times 6. They're both 15 times 6, and 15 times 6 is 90. So that's 90, and this is centimeters, so centimeters squared. 90 centimeters squared. Now we want to find the front and the back. So the front of this shape would be like this, right here, and then the back would be back here, which you can't actually see, but it's back there. So the front is, it's 15 across, right? This rectangle is 15 across and it's 8 high. So these would both be the front and the back, since they're opposite one another. It would be 15 times 8, 15 times 8, and 15 times 8 is 120, so 120, which would be 120 centimeters squared. And then finally, we have the left and the right side. So this would be the right side right here, and then the left side, which we can't see, would be over here, and that is 6 centimeters across this way, and up and down it is 8. So 6 times 8, it's 48. So 48 centimeters squared. Perfect. And then finally, I would want to find the actual surface area. So the surface area would be if I added all of these up together. So I know that 90 and 90 would be 180, 120 and 120 would be 240, 48 and 48 would be 96. And then we can keep adding these. So 180 and 240 would be 300, 420. And then plus the 96, plus the 96. So the surface area would be 514. 516. Sorry, it's very late. 516 centimeters. Oopsie. Centimeters squared. Yay. So that's pretty much what we're doing. So if you want a second example, I'm going to go ahead and do a second example, but this is essentially what's going on the whole time. Okay, a second example would be, this is one doesn't have that nice little table, but I'll use different colors to differentiate it. So the first thing, I'm actually going to find this little side piece first, this guy right here, because I already have those two measurements right next to it. So I know that this face right here it's 9 high and 5 across, and then that would also be this side over here. So I have 2 of these, and that would be 9 times 5. Okay? So I've got, and remember this is the distributive property, so this is saying that there's really 2 of the 9 times 5. So 9 times 5, then times 2, because it's 9 times 5 would be this area, the surface area for this side, and then we have a second one over here. And then the next one I'll do is the top. So that would be like this one, which is also on the bottom. And that one is, I know that it going across this way, it's 20 from this guy right here. And going across this way, it's going to be 5, because the 5 is also right there. So that would be 2 of 20 times 5. So 20 times 5 would be 1, and there's 2 of them. And then, so notice I'm writing this slightly differently, but, and then we have this face right here, which is the same as the back, and this one is 20 across, and how high is it? It is 9 high, which we get from over here, because this is also 9. So 2 of 20 times 9. 20 times 9. Okay. So this one would be 2 times 45. This becomes 2 times 100. I'm just simplifying this step by step. This would be 2 times 180. And I'll just use the red for it. I'm adding them all together. And so then this would be 90 plus 200 plus plus 360 would be 650 centimeters squared. And remember, even though it's a 3-dimensional figure, we are solving for the surface area, not the volume. So it's not filling anything, it's just covering stuff. So there's a second example. Super long, but hopefully it helps you out if you need some help. Have a good one.